switch over here. Oh, before I forget, I'm going to, at the end of the talk, and I can't see anything at all here, I'm going to give away this book copy. So we're going to pass this high-tech security container around. And if you can just put something in there that's identifiable that only you will be, it could be a business card, that's fine. But if you just want to put a piece of paper with something that you know at the end that we can pick it, and I'll give this away at the end. So we'll just pass that around. Let's see if this holds up. I was freaking out with it before. Okay, so I'm going to talk about how we use networks in live entertainment control media systems. So not so much in broadcast or the sort of movie business, post-production, stuff like that, but more in live shows like the one we're at right now. I'm going to talk about some examples of the show networks, and then I'm going to give away the book at the end. Okay, so who am I? I'm a professor of entertainment technology here in New York and City Tech in Brooklyn. It's a bunch of our current and former students are doing a lot of the AV around here, so you might have seen some of them. I'm a member of IATC local #1 stagehands. I'm off access to the screen there. Wrote this book. I'm going to give away a copy here in a minute. I was a subject matter expert for the ETCP Entertainment Technician Certification Program. Oh, sorry. Okay. I unfortunately can't do anything about that right now, but I'll talk through it. I'll violate the golden rule of PowerPoint and read the slides. So, and I've done a whole lot of stuff all over the business. Of course, it looks fine on my screen. There's something going on in this HDMI to SDI box here. So just going to ask a couple of questions, and I can't really see, but if you can raise your hand if you have no networking background at all. Just a couple people. Intermediate, bunch of people, and advanced. Okay, so about 50-50 with that. Have you ever heard of DMX? You've heard of it, that's fine. RDM, ACN, Dante, ABB. Okay, that's good. So that's kind of where I was aiming to talk, people with some networking background. But obviously in 50 minutes I can't explain all this stuff, but every one of those things is in my book, which of course is for sale on my website, Amazon. So does anybody here has worked on shows, live shows? Okay, good. And mostly lighting, sound, video. Okay, great. Yeah, right. So we've come from, I graduated from college in 1985. Back then, there really were no networks in our industry. And then in the 1990s, around that time, a few sort of proprietary networks were attempted. There was things called MediaNet and things like that that were sort of made to address the needs of our industry. And then Ethernet, of course, existed then, but it wasn't really very good for what we were doing. And the reasons was the basic Ethernet has a built-in random back-off time after a collision, and we don't like random in our business because if we want the light queue to go now, we don't want it to go now today, and then a couple of seconds later tomorrow, and maybe 500 milliseconds the next day. If you're doing that on the magic show and you just gave away the trick, then you're fired. So we don't like things that are random in our business. So timing is very important for us. So Ethernet was not a great solution for that, but we ended up using it anyway. Oh, thank you. Yeah, I guess it's actually washing out in the converter because it looks all right on my laptop here. So the Ethernet random backoff issue is solved now because we have full duplex switches. And then now networks have really become, just in the last 10, 15 years, are really a backbone technology of almost every kind of show. Up to like here, I actually helped prep the sound system the other day here. That does not have a network in it, but it's partly, we kept it very simple because we don't know who's operating. In that case, it's easier to troubleshoot with some of this other stuff. But certainly if we're going to do this show, we knew who the staff was, we would make it definitely built around a network. So benefits of networking for us on a show is we have error detection built in. Sometimes we're firing dangerous things, pyro, machinery, stuff like that can hurt people. So it's really important that the data gets to its intended location intact and correctly. So that's built into Ethernet with a CRC check. Electrical isolation, that's a big deal for us too, because we're often connecting to things like dimmer racks, like that would be running these lights. They're high-powered devices. Don't usually want to connect that to a low voltage kind of computer, but Ethernet has built-in transformer isolation in it. Huge bandwidth by control standards, so if we're sending like lighting control to run these lights here, which is almost certainly based on DMX, the amount of bandwidth we have in the network is huge compared to that kind of control. I think I just sounded like Donald Trump when I said huge there, but so today, almost every system you're going to see on a show has Ethernet in that department at least somewhere, and we'll go through each one of those. And yeah, we're starting to see now in professional audio for distribution of audio for live sound applications, we are seeing that now over just standard Ethernet because we have enough bandwidth, and we have this system called Dante, which has become very popular, and AVB also. So what's been interesting in my career, like we didn't have any of this stuff when we started out. Now it's everywhere. That's had a big impact on the designers and technicians because younger people that kind of grow up with this stuff really kind of have an advantage to people like my age who weren't really staying on top of this stuff because they just didn't have the opportunity to learn it. And we're always, in the middle of a show is not a good time to be experimenting with things. So we try to learn things outside and then bring them to the show. If you know understand how it works, we can make very reliable systems out of this stuff. And then since networks offer so much for so little, so there's so much power available in the network today that it's really a core technology for our industry. So people like in our school, we actually teach it. It's a required class for all of our students. That's not true in a lot of other schools. So I think that's a problem that in the industry, the training and the expertise is lagging a little bit behind us. We have this thing. It's not a new technology in the world. It's new for us. And a lot of people just don't have the background and experience. There are certainly people that do, but so that's an issue. It's kind of a transitional thing for us now. So what's different about a show network? For us, we don't put many show networks on the internet for obvious reasons. We don't want people messing with it, but also we don't want the thing to run Windows or Apple update in the middle of the show, because if you're trying to run 40 sound cues at once is not the best time to load down the processor with something else. So if it's not on the internet, it makes that a little bit easier. There are some types of performance where, like we did a show a year or two ago where we had live Twitter feed to the screen, so obviously those machines were connected to the internet, but we actually did it with two separate NIC adapters and really segmented out as much as possible to do it. Also, we work in a difficult physical environment, so they were here until 4 o'clock this morning loading in all this stuff, dragging it through the hallways, in and out of a truck, and if this was a tour, it would go back in the truck tonight, go somewhere else, get unloaded the next day. So our solutions need to be heavy-duty stuff just in general. So that's not something, obviously, RJ45 connector was never really designed for that kind of use, and we have some solutions for that. So we're much more like a factory than an office. We can use it for dangerous stuff. We can fire pyro with it, moving scenery, huge moving scenery sometimes, half of a building, whatever it is we're doing. So all these things, this is something we have to take into consideration when we're designing this stuff. Also, this idea the show must go on. Reliability is really critical for us, so we often have redundant systems. We often have very strong sort of boundaries between systems, so we can say, okay, no, it's working up to this point, and go over here. Sometimes that means we build things that look kind of crazy from a sort of traditional IT perspective, but it's important for us that even if lighting has a problem during the show, sound and video and scenery still need to be able to keep going. So we have to factor that in our system. And that's the other problem we have, or the reason why the show will have to go on. That's our product. That's what we sell. And what I mentioned before, we have to be able to get the system working now. So that's why I have a picture of Scotty crawling around in the enterprise there. We don't have time for that in a lot of cases. So you can't like wait and call the building engineer to kind of come up and fix it, or the IT department who went home already and now it's 8 o'clock on a Sunday. Nobody wants to hear, well, we had to send everybody home because there's nobody here to reset this router or something. It's not acceptable. And if you're dealing with like a typical Cirque du Soleil performance in Las Vegas, if it sells pretty well, that's worth about $250,000. So, or a Broadway show, let's say it's 800 seats, multiply that times $100 seat ticket or something. Talking about big money, so we build in redundancy and have a lot of extra stuff around and simplify things as much as we can. And also the staff on the show is not likely networking experts. I mean, we're getting that now, but we also don't want to, and the other hand is, the other part of that as well is we don't want, oh, thank you. If you have somebody that's a certified networking person, but they freak out under pressure, it's not going to work for us, right? Because you have to be able to deal with that. I was helping out my former student over there in the audio in the other room, and I just walked up to the board, which I saw for 5 minutes on Thursday, and I'm EQing it in front of 500 people. And I've been doing this a long time, so I know what I'm doing, but that's pretty nerve-wracking when you get going on it. So same thing with a network, you need to have people that can deal with that who may not be the same people that are the ones that are going to come in tomorrow and reset your system. That's too late. We already lost the show. On the other hand, it doesn't necessarily mean we have to do the same show every time. We might have a fallback production or something. And most times for the audience, when something really goes wrong on stage, that's like their favorite thing ever. They see the whole thing stop, and we're horrified because it's a big train wreck, and people are like, oh, that was so great. The stage manager came out and told everybody they had to wait 5 minutes. So for us, but we want to avoid those moments as much as possible. In a permanent facility, we overlap a lot with the IT departments, and we're fighting for jurisdiction with them. This is a very interesting, never-ending topic, especially in a building where you have to build this. Like, for example, in my school, the IT department knows what we're doing. They stay out of it. We do our own thing. We run our own cable. We do everything separately. And then if we need to connect to their system, we get a specific thing with a port, and then we manage that. Other places, though, if you're like working in a big, corporate office with a lot of conference rooms and stuff, the IT people are like, oh, all these AV work, we want that. And then again, though, they have to be able to deal with that when the CEO wants something right now. It can't be, you have to have the people that can deal with those kind of people. And what's so interesting in the business is often, we're in the loading dock dealing with the freight elevator operator, next to the garbage compactor in the morning. And especially if you're like in the sound department, then you're handing the mic to the actress or the talent or the singer or the CEO that evening, and you have to be able to deal with both those kind of people. So some people just aren't right for that. And then just in the culture of IT, it's changed a lot because IT, we can't do things without networks in a lot of cases. Not just us, but any business can't operate without a network. I know when I'm at school, if the network goes down, I just go home. I can't do anything unless I'm in the middle of class or something. So this is like a constant struggle with us. But on most temporary shows, we just have nothing to do with the IT departments. It's more in like permanent facilities and theme parks and stuff like that, where this is a kind of running skirmish with them. So on a show, we tend to divide the work up by department. So even like here at this show, you have a lighting, somebody, Maya, the head of lighting, and Courtney's here for audio with Aaron. And then video is Andrew. These are all former students, is why I know who they are. They all work together, of course, but you have to have one person in charge of each thing. And often that means that we're going to build redundancies. So the lighting department will build their own network, might use switches from one company. Sound would build their own network from a different company because it comes out of a different shop and somebody made a different decision. But we keep it that way because they really don't interact very much, and that way if the lighting network crashes, sound can keep going and so on. So that's a really important concept for us. We're also a small industry, not a lot of R&D specific to really serious R&D in our industry. And I haven't looked it up in a few years, but the last time I looked, the revenue of GE alone was larger than all live performance budget in the world. So compared to that kind of industry, we're still very small. It's gotten a lot bigger than it was. So we're basing things around that. So we often will use solutions we've kind of borrowed from other industries. And we have a whole history of that. In fact, I did a talk here 4 years ago or something like that, talking about how we kind of adapt technologies. We call it hacking for an audience because we're really adapting technologies from other fields. Also, within our industry, we use do a lot of system integration by solutions that are packaged up by manufacturers. So, for example, right now there was kind of a battle, not really a battle, but a decision to be made about which audio network to use, and some people are trying to pick by the network. and one might be technically better than the other. In the end, as end users, it doesn't really matter which one's better. It matters which one I can use today. So one manufacturer, in this case with Dante and Yamaha, Yamaha is a very big, they're a big manufacturer in the industry. They chose this technology, and if you use Yamaha, you use that technology. So then we have to kind of go along with them. So we don't often get to, or even necessarily want to design that sort of low-level back-end stuff. That comes to us from the people we buy gear from. And so in that way, we have a lot in common with the industrial controls and factory automation market. So we do use some pieces of gear from them, especially if we're doing like a scenic automation system. That is basically their gear. We just use their stuff because it's the same thing. And that said, we do have some show-specific hardware. So the switch on top is made by a company up in Canada called, it's what's called Pathway, but they got bought by somebody, so the name is very complicated. But that's basically a standard switch, but it knows about the protocols we use. It has these kind of connectors on it. If you can see that, that's called an EtherCon connector, so that's a standard RJ45 connector that fits inside of a shell that's the same size of an XLR connector, which is what comes out of this microphone. So we already know we have panels punch this size, all this kind of stuff is there. Now we also have that same company, Neutrik, is making a similar thing for fiber. So that's a dual fiber connector, a heavy duty thing that's easier for us to unplug and plug. Because something in a big machine room in a data center, they're not going to be unplugging their fiber run every day necessarily. In most cases, they're going to plug it in and then don't touch it until something breaks. Us, if we're on tour, we might plug this thing in and out every single day, throw it in a truck, get in the rain, do something else. So this switch is set up to, it either takes a standard RJ45 or it'll take one of these connectors, which is locking. There's no stupid plastic tab to break off. All those things. And then again, it just has a knob so you can set some VLANs in there without having to go to Cisco school or anything like that. And also you can set it up to just be aware of the protocols we use. So some lighting control protocols, some sound ones that we use. You just set up, say, hey, I'm running Dante on this thing, or I'm running streaming ACN, which I'll talk a little bit about these. Boom, you're done. You don't have to go figure out how to do it and accommodate it. So again, we mostly do sort of systems integration and try to put all these things together. So what's happened for us, show networks good and bad. In our field, we're very sort of hands-on, mostly very hands-on people. I include myself in that, dealing with sort of abstract ideas of networks. And like me, I'm very number challenged, but this is everything I do is heavy in numbers, so we figure out a way to deal with it. But the cool thing is that's really been good for our industry is in the past, if you learned, for example, DMX, which is a very widely used lighting control protocol, that had nothing to do with sound, right? So other than use a similar looking connector. So if you're in the sound department, no skill that you had really other than how to do a show and not freak out under pressure and things like that. But technically there was no sort of technological overlap. Now we're all using networks. So if you know what an IP address is and you're in the video crew, you can go to the lighting crew and you still know what an IP address is. So that's actually really good for us. On the other hand, it's really hard for people who've been in the industry for a long time that are very sort of hands-on people to deal with networks because they're very abstract. And it's all these just numbers and weird stuff, so it's difficult with that. The other good thing though, once we have this sort of unified interface or access, we can, it's much easier to troubleshoot, but that also means now we have a common failure point. But again, it means that you have some expertise. Maybe if you're having problems in sound, the lighting guy can actually help you out because they know networks or whatever. So it's been a very interesting transition. This is really only in the last 10 years that this has become true. But the other good thing is I think we're there. We're not going to go back. Networks are here to stay. Maybe we go to IP version 6, probably not in the short run. So once the people in our industry learn this, they know it and they can move forward with it. So that's really good. So I'm going to talk a little bit about each area. Start with lighting. I mentioned this a little bit already. Really, lighting doesn't do anything without control. I'm just reading the slide because I know it's kind of blown out there. But for a generation, the industry is based on this DMX 512 protocol, which was designed in the mid-'80s. And in those days, you just had conventional filament fixtures, no LEDs, no moving lights, nothing, and dimmers. So it was very kind of accommodating what it could deal with. And we didn't need all that much. You run a cable from here to there, you have a point-to-point connection, you're ready to go. So also in the last about 10 years, there's another protocol called remote device management that's been coming around. That rides in the back of DMX, allows you, for example, if we had a moving light over here, we could set some parameters in the moving light without having to get a ladder out and push some buttons on the back. Also, we can monitor lamp hours and things like that. So that's come in. It's finally starting to catch on a little bit. That's a long story. But that runs on top of DMX. So that's sort of where we were sort of prior to networks, although RDM's sort of after that. The timeline's a little bit simplified here. So that point-to-point infrastructure is really limiting, but a network, just one single, even the lowest bandwidth network, can carry many, many, many channels of lighting data. So that's a big thing as our shows has gotten very much larger and more complicated. ArtNet was a protocol made by a guy in England named Wayne Howe, a company called Artistic License, and he made this protocol, I can't remember when, but a while ago, and just put it out into public domain. So he owns its proprietary standard, but he's put it in the public domain so anybody can use it. It was designed in a time when we weren't doing very large scale systems, so it works really well in a small kind of, one, like in this room it would work great, but it defaults to routable Class A IP addresses. It just repeats the DMX information over and over and over again, which can kind of look like a broadcast storm and things like that. So it works fine, but it's not really, there's better solutions now moving forward in networking. So one of the ones was developed recently called ACN, or Architecture for Control Networks, and Maya, who was running the whiteboard in the other room before, is one person who's really, really involved in this, is a real expert on this. Unfortunately, so ACN was really designed to replace all this old point-to-point stuff, and unfortunately the industry wasn't really ready for it and didn't adopt it, so it was pure network-based standard. But we did take a subset of that, called streaming ACN, to take our lighting data and put it out over this sort of DMX, DMX-like, it says date here, but it's data. So that's now, that's our alternative to ArtNet, and that one is a very modern network-focused protocol that deals with all the issues, multicast, all these other things that we have issues with in modern networks is all covered by that. So that's now, those two, streaming ACN and ArtNet, are the two most widely used lighting control protocols in the market right now for networks. I would prefer streaming ACN myself, but they'll both work. And these are used in a lot of cases, like in here with a few lights, maybe you don't need it, but if you're going, doing a big concert where you would have had with the old DMX stuff, you would have had 50 cables from your console up to the lighting truss. That's a pain in the ass to put in and out every day and to deal with and all that stuff. So now we can run one network cable and just carry all that same data up there. So that just practical reasons like that is really what started the adoption. There's a lot more capability for sort of interactivity and lots of cool stuff in lighting, which hasn't happened and has been slow to happen. And I'm being a sound guy, I can beat up on lighting people, but it's just unfortunate because sound, we move way beyond things we used to do, and lighting is kind of stuck in this 20-year-old technology. However, it works fine. It does everything they need to do today. I don't think it's really going to do everything they need to do tomorrow, but that's where the market is. So like ACN really kind of failed in the market, but streaming ACN is there, and that's at least now we have a network way to do it. So I think I'm optimistic that over time, the next generation coming along that's comfortable with networks will see some of the potential and do it, but I've been wrong before. So you'll see things, I found this just on the internet. This is a lighting system based on Grand MA system, which is there's two, at least in New York, there's two very popular systems, Grand MA and then ETC, which is what you'll see around here. ETC is a little more theatrical oriented. Grand MA comes more from the concert and event market. But I mean, that's a relatively complicated network just for lighting control data, but that really is the backbone of everything that we do now in a lighting system is based on a network. And you're going to see a bunch of diagrams that basically all look the same because it's the way you would do it now. So it's just very straightforward. This one I know you can't read, but this is from Broadway production of Rocky. And what I just left this part in because you can see this green line going around here is a big fiber ring. So what they did is they just ran a ring of fiber all around the theater, and then in each area they had one of those switches like I showed you the picture before that had fiber in, and then it actually comes out into the DMX or network, whatever's needed locally on each one. So in that case, we're using it like as a big backbone around the theater, and then it comes out to the individual things. Because in the end, there's only a few products in the market that will take Ethernet-based protocol directly, but everything will take the older serial protocol, DMX. So that's sort of where we are at this point. But so you're seeing that. I mean, it's a fairly sophisticated network, although my friends that work on these shows say the biggest maintenance issue they have is the Wi-Fi in the dressing rooms, right? So it's not the lighting system works great. But actually, a funny story, my friend one of my colleagues at school who subs in, I think he was on Book of Mormon, and these systems are pretty reliable now, but he actually had an audience member, like at 7:58, came up right in front of where he's out in the house and tripped, and their finger came through. They weren't doing it as a purpose, it just ran, and their finger came through and hit the power button on the console. So it was like, say, 7:55, he's like, oh, and he's on a headset, I'm out, I'll be back. And it takes a while to reboot, and you have to reestablish all the connections. So we always worried about crazy, gremlins in the network, and then so now they have a metal plate mounted over the power button. So it's almost always some power switch or something like that. So in sound, we haven't done as much distributed control in sound, but what's been happening now with everything moving to DSP, I'm jumping out of my slide, but traditional sound systems were totally analog. This system here is totally analog because it's just simple and the equipment's inexpensive, easy to use. But in the 80s, we started seeing digital consoles come out, and that moved into some networking. There was some there's some proprietary networking standards, like CobraNet was used very widely in permanent installs as far back as the 90s. That was more like you'd see in an airport or convention center or something like that, because in there you have big economies of scale. It's very cost effective to run one Cat5 cable instead of a whole lot of analog stuff. But then you need a level of expertise. It's harder to troubleshoot all those kind of things. And then just recently, this proprietary system called Dante, made by a company in Australia called Audinate, they were adopted by a number of the big manufacturers in the live sound market, and they have become kind of the de facto standard in this. There is another thing that actually predated Dante a little bit called ABB, or it's actually changing its name to TSN, which is time-sensitive networking. That was adopted by a couple manufacturers, including the people who make these speakers. Actually, Meyer Sound was big in ABB, but this year at the big trade show, they've announced they're going to support the Dante, so they're going to have both. And I have a huge series of articles on that on my blog if you want to read about it. It's been kind of fascinating to watch. But now really, so we are doing, except in all but the smallest things like this system here, any system that starts to scale up at all, the networking just is so much, it's just so much easier. There's a lot less cable to run. I was talking to the owner of the sound company on Thursday. We were prepping the system for this thing, and he was like looking at a big heavy duty Cat5 cable that he'd gotten, and I was saying, yeah, this thing is like $500, even though it's an expensive cable, but the analog snake that it replaces is probably 10,000 or 8,000 or 7,000, and much more. So if this thing breaks, you just replace it. If you're on tour and something goes down, you can go to Walmart and buy another Cat5 cable. Right, so that's why we're doing it. There's a lot of reasons. And then also from the distribution standpoint, networking and things like Dante make that a lot easier. So kind of typical sound networking, like you might see, this is from Yamaha, which is one of the bigger, they're sort of the workhorse, I call them like the Chevrolet of sound consoles. So you see these things all over the place. And the gain's actually going down in here. It's getting really weird. So I'm getting less echo. Everybody can still hear okay? Okay, good. Maybe it was too loud before. So down here we have sound console, and then this one they actually have a VLAN set up, but then instead of running a big heavy bunch of analog mic lines and stuff, you just run a network, and then you have this, they call it a Rio box, which is input-output box, and they have a stage box here. And the cool thing is with this, once you have your system converted from analog to digital into the system, then you can distribute it very easily. You can also copy it 12 times if you want, do whatever you want without any sort of degradation. We do, like I said, the system, when it's implemented in Yamaha's system, has a fully redundant network with 2 completely separate switches, and this thing works. I've tested this myself. If you just yank one of the plugs out, you won't even hear it. It won't even miss a sample. It just rocks solid with that. The only downside is in this system, like no red light starts flashing, so you could lose a whole link and not know it. Then you lose a second one, you're screwed. So a lot of places, a lot of applications that would try to transmit audio or video or things like that and have not a robust transmission medium would just buffer the hell out of it. That doesn't work for us. If we have in-ear monitors on a performer, we need to be like less than 7 or 8 milliseconds, or else they're going to perceive it as an echo and throw their in-ear out on the floor, and freak out. So we don't want that to happen. So that on a like stage monitoring in the live sound system itself, we have lots of room for delay. But in the in-ear monitoring case, that's our sort of worst case scenario. It has to be as short as possible. And of course, in an analog, it's microseconds. You can't even perceive it. So that's an issue with that. So this is done more for reliability. But so this particular system, Dante, there's other ones out there, but this is really the dominant one. The market has a latency through the network of about less than 1 millisecond. So that's pretty good. And then you have processing time. It takes about a millisecond to convert A to D or D to A. And then it's a little bit, so you could get through one of these systems in 3 or 4 milliseconds, which is close enough for most things. Of course, there is ways with less switches to do it faster and so on, but that's sort of a baseline for that. This photo I found also online. It's so low res, I know you can't read it, but the point I want to make with this is on this one we have lots of sound consoles on one network and then only a few I/O points. So if you're doing the Grammy Awards or something, which that was missed on Digico, but another one of those big awards show was actually on CL5. But anyway, so you have one input from Adele or whoever from her microphone, and then you have monitor mix for her, you have the live sound mix. These are all different people with different consoles. Monitor mix is one person, live sound mix is another one, and then the TV broadcast is a third one. So you have at least 3, and then maybe a recording one might be 4. So with a network, in the old days of analog, that was kind of a nightmare of ground loops and splits and transformers and all this stuff. Now we just put them on the network, and then you take input 17 and just copy it to every console. The only issue then is who's controlling the gain of that thing. That you have to work out. And that depends on which manufacturer you're dealing with. Video. So video is, again, almost any video display system today is built around Ethernet for non-real-time distribution. So right now the video bandwidth is so large that there's a few solutions starting to float around. There's some in kind of permanent install systems, but in a live show, you're seeing more stuff like this. I don't want to touch this because this was freaking out before, but this BNC cable here is what's called SDI, which is going back to the projector. That's not a network. It's actually an old piece of coax, but that's sort of the professional broadcast standard now. And then we use things like HDMI and stuff like that. But there are ways. There is a thing now called this is called HDSDI, and then the other one you see there, HD-Base-T, is a way to send HDMI video over a Cat5 cable, but it's not a network. It's just using the cable. It actually can transmit a low bandwidth network for control, but it's really about the video. So that's just using the cable infrastructure, but it's not a network. But what you do see, though, is on a lot of display systems, you'll see the synchronization and media transfer and all that stuff on the backbone of, of course, on a network. And I haven't heard from my friends yet if anybody saw the RNC. During Ted Cruz's speech, the video server was crashing. And a friend of mine on Facebook promised to tell stories when he gets back from that and find out what happened. But you're kind of walking on a high wire in these things, and you have thing work great, for weeks and weeks, and testing in the shop, you put it in, everything's fine, and then you get one more, power fluctuates or something changes, and now it doesn't work. So this is why you have to have backup systems and all that kind of. It's hard to have a backup system for a video that big. Scenery. So a couple of things in scenery. A lot of automated scenic systems. We use Ethernet as a control backbone. This is a system called Beckhoff, very widely used in theme parks, but also as the backbone of companies like Stage Technologies, Tate Towers. Those kind of guys, or sorry, Tate, not Stage Technology, but they're moving to it, use this. And then just using standard off-the-shelf Ethernet infrastructure, sometimes they have a slightly variant of that I'll talk about in a minute. And then this kind of box can provide whatever I/O you need. So if you want to have sensors over here in your dark ride, you can, instead of running analog cable all over the place, you just run an Ethernet network, plug it into your box, and then wire into that box. That's what I was talking about, that, Beckhoff. So there are, of course, we're dealing with machinery. Companies like Beckhoff actually offer using standard IP and or standard Ethernet anyway, they actually have a safety rated system inside that. So they build their own safety system within that. Because if you're talking about machinery control stuff that is dangerous, can hurt people, that's really, really important. So but now they figured it out because just again, the scale and the economy of being able to send this stuff over a standard network and standard Cat5 network. In their interest to do that. So
if we see that manufacturing,
yeah, it's the same as everything else. Great. So I think we have 2 minutes left. Any other questions or 1 minute left? Oh, sure.
Are you doing VLAN separation for safety? Is that your primary concern? Because on an isolated network, right?
Yeah, and that's a good question. Are we using VLANs for safety? Really, it's more because we can, and it just sort of it's kind of overkilling it, which we like to do. In reality, even that haunted house, with everything going, like when I look at the show control system network utilization, it's like 2%. Even Dante with like 48 channels of whatever is like maybe 5 or 10% of the network. So bandwidth-wise, we can handle it. Obviously, the same switching fabric's handling all that stuff anyway. It's really more kind of ass coverage. So if something happened in this lighting system and it had just had a broadcast storm and started going crazy, then the lighting and video and those kind of things wouldn't be affected by it. It's not really for a bandwidth reason. It's more just sort of operational. We're always planning and anticipating how can things go wrong, and then what does that failure mode look like, and how can we avoid it? So that's kind of the approach for that. One more question? Oh, sure.
So do you have any sites that you suggest for kind of like a local? My dad helps a local theater.
Uh-huh.
I want to kind of keep him abreast of like what the DIYers are doing and like an entry level to kind of keep an eye on the technology from that perspective. Instead of having, because he doesn't have really resources, so it'd be a good resource for kind of entry level.
Yeah, I think.
stuff.
Yeah, I think, but the question is there a good source for entry level AV stuff? Entry level AV is you still want to stay in the professional world because there's a lot of things like here we have HDSDI, which you're never going to see in somebody's house. But there's a very good reason that we use it. It's really not that expensive in the big picture. So I would kind of just stay in the low-end professional stuff. And there's lots of resources for that. I have a blog that I write about this stuff. So great. And last call of anybody to win the book here because we're out of time. Anybody didn't get their card in here, run up here very quickly, stick it in, and then we're going to draw it. Nope? Okay. Yeah. All right, that's the last one. Dump it on the document here. I'm not going to I'll throw it on here very quick. Right. As long as you can identify it. All right. Oh, I have a card. Oh, interesting. Let's see. Barry Rosenberg. Oh, there you go. Great. And thanks very much.